Hi and welcome back. So in the past video I gave a little bit more of a clarification on Millikan's oil drop experiment and how exactly the experiment was done. And what I'm going to do in this video is I'm going to give you some notional data, so some data that, maybe Millikan could have gotten by doing this experiment. And we're going to see what result we get for the charge of one electron when we work through this. So let's say we're going to have 5 different trials. So we're going to have 5 different trials. And let's say in the first trial, we had to, the amount of electric charge that we had to apply in order to get our drop of oil to stop moving. So if you remember what we're trying to do, let me just scroll up again. What we're trying to do is we're trying to apply some electric charge that makes this ionized drop of oil stop moving. And so let's say the first charge, or the first trial of our experiment, we found out that it took minus 36.8 times 10 to the minus 19 coulombs. That was the amount of the charge that we had to apply to get that drop of oil to stop moving. So that's our first charge, or our first trial. For our second trial, we found that it took minus 30.4 times 10 to the minus 19 coulombs to get the oil drop to stop moving. For the next trial, for the third trial, we said it was minus 19.2 times 10 to the minus 19 coulombs. For the fourth trial, we found out that it was 9.6 times 10 to the minus 19 coulombs. And then for our final trial, for our last trial, we found out that the charge we had to apply was minus 11.2 times 10 to the minus 19 coulombs. And we are again going to try to figure out, based on this data of how much of a charge we had to apply, what is going to be the charge on one electron. So what is the charge of one electron? That's what we're trying to figure out. So we're going to go about this in really a very similar way that we did in our apple picking example. Let's just, and we can almost see from the beginning that we're going to be wrong, but let's just guess, let's make a first guess that maybe minus 9.6 times 10 to the minus 19 coulombs, maybe this is the charge of one electron. So if we were going to divide all of these other numbers by this charge, we should get whole numbers. We shouldn't get fractional answers. And probably you can already see that that we are going to get fractional answers. But let's just still make this first guess, because it's a good starting point. So the first thing I guess I want to point out is that for these trials, we're going to be taking the ratio of two of these numbers a bunch of times. And actually, let me just write down the first ratio. So let's take the ratio. Let's take the ratio actually between minus 9.6 and minus 19.2. So let's first take the ratio with these two numbers. So on the top, we are going to have minus 19.2 times 10 to the minus 19 coulombs. And then on the bottom of our fraction, we're going to have this, which is our first guess for what the charge of one electron would be. So that would be minus 9.6 times 10 to the minus 19 coulombs. And one thing I just want to point out to you before we go any further, because writing these out, I am going to simplify them a bunch. Do we have to write all this other stuff along with our expression? Do we have to write the minus sign and the times 10 to the minus 19 coulombs? And you can see that, no, we really don't have to do that. We can ignore all of this stuff. All we have to do is we just have to divide 19. Let me actually just scratch that out so it's actually nothing there, not a plus sign. All we have to do is divide 19.2 by 9.6 and figure out what our ratio is. So let me go ahead and get out our calculator. And so we have 19.2 divided by 9.6. And so that we actually get a whole number answer to start out with. We actually get, and let me scroll over a little bit, we actually get from this first trial that this is equal to 2. So if this was the charge on one electron, say this drop of oil actually could have had one electron in it, and you can probably see that that's not too probable. But imagine that, we had this one drop of oil that did have one electron in it. And so therefore, this drop that had a charge of minus 19.2, that would have had 2 electrons in it. So this is pretty much what we figured out based on our first guess, or what we think we figured out, I guess. So now let's start taking some more ratios. So now let's take the ratio of maybe 11.2 divided by this charge of minus 11.2 times 10 to the minus 19 coulombs, divided by our first guess for what the charge is on one electron. So let's go ahead and we're going to say, and we'll drop all this other stuff for right now so it looks a little bit nicer. So we have minus 11.2, and we just have to divide that by 9.6. And let's see what we get. Get the calculator. So we have 11.2 divided by 9.6. And look, we don't get a whole answer. What do we get instead? We get 1, and then we have this, and maybe this looks kind of messy, and I kind of wish I had a calculator with a key that would let me express this as a fraction. But let me ask you, what is this actually going to be? If we could simplify this down to a fraction, this is actually going to be 1 and 1/6, right? Let me actually just show you that. So if I was taking 1 divided by 6, I should actually get at least that same decimal. And you can see I get it. It's 1.66667. So actually, what we found out, this 11.2 divided by 9.6, so that came out to 1.1666 repeating. So let's figure out now, actually, because my guess is that this is actually going to be 7/6. And that's what it is. So if we wanted to write this as a fraction, so if we wanted to write this ratio as a fraction, it would actually be 7/6. So that is what we have figured out this ratio to be. So if the charge of an electron actually was 9.6, that this drop of oil, it doesn't have a whole number of electrons. It has 7/6 electrons in it. So we already know that this guess of minus 9.6 for the charge of one electron isn't right. We can already see that based on our first couple of calculations. So now let's just keep going. Let's take some more ratios. So now let's take minus 30.4, so I'll just write that down, 30.4. And we're going to take that ratio with our 9.6. And what's this going to give us? So this is going to be 30.4 divided by 9.6. And look, we've actually got this same exact decimal that we saw before. We've got 3 and 1/6, right? So if we had some operation on this calculator, and maybe I'll have to poke around with this calculator and see if it will represent numbers as fractions. But we can see that this is going to be 3 and 1/6. So what could we write this as a fraction if we didn't want to write the I think it's called a complex fraction. If we just wanted to have one number over another number, we could say this was going to be 19/6, right? So we figured out if our first guess of a charge was minus 9.6 times 10 to the minus 19 coulombs, if that was the charge of one electron, we would have 19/6 electron in this blue drop. So that's what we figured out now. And now we've got just one more. Let's take this last ratio, and I'll scroll down just a little bit. So we're going to take the charge of our last drop, 36.8, and we're going to divide that by our guess, by 9.6. 9.6. And this is going to be, so we have 36.8 divided by 9.6. And now we actually get a different decimal. But now, what is this decimal? Because it looks very similar to that 1.6 repeating. Now we've got 0.83 repeating. So this is going to be what is, if we were able to convert this to a fraction, what would this be? And I'll give you a little bit of a hint. Let's take 5 divided by 6. And we actually get the same exact thing. We get this 0.83 repeating. So at this number, let's get back, 36.8 divided by 9.6. What this number would be, if we could represent it as a fraction, would be 3 times 6, so it would be 18 over 6 plus 5 over 6, plus 5/6, so, or 3 and 5/6. So I'm actually going to write that as 18 plus 5, which is 23 over 6. So hopefully I didn't confuse you with that right now, because I just wanted to hopefully I didn't confuse you with that. If that was confusing for you with that doing manipulations of fractions that way, or figuring out what the decimal expansions were of fractions, I would advise you to go and check out the Khan Academy playlist on fractions and on decimal values for fractions and all of that. Anyway, actually, you know what? I'm looking at the clock right now, and I'm pretty much out of time for this video. So in the next video, we're actually going to use these ratios that we figured out to try to figure out what the charge would be of one electron based on this data. So thanks for watching, and I'll see you soon.